Chapter 6.4 Rational Equations. Rational equations differ from rational expressions in that they have an equal sign. We're now able to solve for the unknown variable, whereas previously we just had expressions. We could only simplify the expression. The solutions to rational equations must be verified against the non-permissible values. Here are the steps to follow. Step 1, factor the numerator and denominator of both expressions if possible. Step 2, determine the NPVs. Step 3, multiply each term by the lowest common denominator. Step 4, simplify and solve the equation. Step 5, verify the solution against the NPVs. Note, an extraneous root is a solution to an equation that is not permissible in the original equation. An inadmissible solution is a solution that is permissible in the original equation, but is not valid in the context of the problem. So that would be for word problems. Like if we were talking about our variable representing time and we got two solutions, one that was positive and one that was negative, because time can only be positive, our negative solution would be inadmissible. A minus 2 over 6 minus 5 equals a plus 3 over 3. Step 1, factor. There's nothing to factor here. Step 2, determine our NPVs. In this question, we don't have any variables in the denominators, so we would have no NPVs. Step 3, multiply each term by the lowest common denominator. The lowest common denominator in this case, we have 6 and 3 as our denominators. 6 is a factor of 3, so that is our lowest common denominator. Multiply it to each of our terms. 6 times a minus 2 over 6. Notice we're just multiplying it to the top. So this is different from the last lesson when we multiplied it to the top and bottom, and that was to create common denominators for all of our fractions. Now we are just multiplying the lowest common denominator to each term, which then, if it's a fraction, means multiply it to the top. The reason we're doing this is because it's going to eliminate all of our fractions. Negative 5 times 6, and then equals 6 times a plus 3 over 3. What happens here is the 6's divide out, and then in our second fraction, 6 divided by 3 is 2. We are left with a minus 2 minus 5 times 6 is 30 equals 2 times a plus 3. So as we see, our fractions are no longer, which makes it so that we are able to solve this easily. Step 4, we want to simplify and solve. We have a minus 2 minus 30 is minus 32 equals 2 times a plus 3. So multiply the 2 into the brackets. We get 2a plus 6. Then we want to combine our like terms. I'm going to subtract a on both sides, and I'm going to subtract 6 on both sides to move my a's to one side, my constant terms to the other. I get negative 38 equals 2a minus a is a. So it looks like the solution is negative 38. Step 5, we need to verify. So first we check that our solution didn't come out as one of the non-permissible values, which it didn't in this case because we don't have any. And the second, we plug it into our original and make sure the left side is equal to the right side. Negative 38 minus 2 over 6 minus 5 equals negative 38 plus 3 over 3. Bracket for the numerator, negative 38 minus 2, close the bracket on the numerator, divided by 6, then minus 5. Change that to a fraction, math, enter, enter, gives me negative 35 over 3. And the second one, negative 38 plus 3 is negative 35, and the bottom is 3. That's verified. So a equals to negative 38 is our solution. x plus 1 over 3 plus 4 over x equals x over 3. Step 1, we can't factor anything. Step 2 are non-permissible values. We have an x as a denominator, so x equals to 0 is an NPV. Step 3, multiply by the lowest common denominator, which in this case, lowest common denominator would be 3x. Multiply all the terms by 3x, we get 3x times x minus 1 over 3 plus 3x times 4 over x equals 3x times x over 3. In the first fraction, the 3's divide to 1. In the second fraction, the x's divide to 1. And in the third fraction, the 3's divide to 1. We are left with x times x minus 1 plus 3 times 4 is 12 equals to x times x, which is x squared. Step 4, simplify and solve the equation. Multiply x into the brackets. X times x is x squared. X times negative 1 is negative x. Plus 12 equals x squared. If we subtract x squared from both sides, x squared minus x squared is 0. We're left with negative x plus 12 equals, and then again x squared minus x squared is 0. Add x to both sides. We get 12 equals x. Step 5, let's verify our solution. It's not an NPV, so that's good. Now let's plug it into the original equation. 12 minus 1 over 3 plus 4 over 12 equals 12 over 3. 12 minus 1 is 11 over 3 plus 4 over 12 simplifies to 1 over 3 and then equals to 12 over 3. 11 over 3 plus 1 over 3 is 12 over 3 equals 12 over 3. Then x equals to 12 is our solution. X minus 12 over x plus 3 equals negative 2. Step 1, factor. There's no factoring again. Step 2, NPVs. We have x plus 3 on the bottom of a fraction. When is that equal to 0? When x equals negative 3. Step 3, multiply by our lowest common denominator. In this case, the only denominator we have is x plus 3. That's our lowest common denominator. Multiply everything by that. We get x times x plus 3 minus 12 times x plus 3 over x plus 3 equals negative 2 times x plus 3. In our second fraction, x plus 3 and x plus 3 divide to 1. We are left with x times x plus 3 minus 12 equals negative 2 times x plus 3. Step 4, we want to solve and simplify. Multiply the x into the brackets. We get x squared plus 3x minus 12 on the left. On the right-hand side, multiply the negative 2 into the brackets. We get negative 2x minus 6. If you are going to end up with no x squared value, then you want to move your x's to one side and your constant terms to the other. If you're going to end up with an x squared term, you want to move everything to one side, have the other side equal to 0 so that you can factor or use quadratic formula to solve. I see that I have an x squared term and it's not going to be subtracted because there's no other x squared term, so it's going to stay there. I want to move everything to one side then. Plus 2x plus 6. I also want to keep in mind that I'd prefer to have the x squared term positive, so I want to move everything to that side. In this case, that would be the left. Add 2x and add 6. We get x squared plus 5x minus 6 equals to 0. Then we want to solve this by factoring or quadratic formula. I'm going to factor this. I want two numbers that multiply to -6 and add to 5. One has to be negative, one has to be positive. 6, -1, 6, -1. Those multiply to -6 and add to positive 5. X plus 6, x minus 1 equals to 0. What are the solutions? Well, when is x plus 6 equal to 0? When x equals -6. When is x minus 1 equal to 0? When x equals to 1. Last step, let's verify. We check our solutions -6, 1 with our NPV, which is -3, so that's fine. Neither of them is the NPV. We want to sub them into our original equation. I'm going to start with 1 minus 12 over 1 plus 3 equals -2. 12 divided by 1 plus 3 is 4, so 12 divided by 4 is 3. 1 minus 3 equals -2. 1 minus 3 is -2, which equals -2, so that's verified. And then I want to do the other solution, -6. -6 minus 12 over -6 plus 3 equals -2. -6 minus 12 over -6 plus 3 is -3. -6. -12 divided by -3 is plus 4 equals -2. -6 plus 4 is -2 equals -2. We have verified both solutions, so x equals -6 and x equals 1 are both solutions to this equation. Nine over y minus 3 minus 4 over y minus 6 equals 18 over y squared minus 9y plus 18. Step 1, can we do any factoring? Yes, we can factor our third denominator. We have 9 over y minus 3 minus 4 over y minus 6 equals 18 over. It's a basic trinomial. We want two numbers that multiply to 18 and add to -9, which would be y minus 3, y minus 6. Those multiply to positive 18 and add to -9. Step 2, NPVs. We have factors of y minus 3 and y minus 6 in our denominators. Y minus 3 equals to 0 when y equals 3, and y minus 6 equals to 0 when y equals 6. Those are our NPVs. Step 3, multiply the lowest common denominator to each of our fractions. Our lowest common denominator would be our two factors that are in our denominators, y minus 3 and y minus 6. If we multiply that to each fraction, we get 9 times y minus 3, y minus 6 over y minus 3 minus 4 times y minus 3, y minus 6 over y minus 6 equals 18 y minus 3, y minus 6 over y minus 3, y minus 6. Then in the first fraction, y minus 3 divides with y minus 3. In the second fraction, y minus 6 and y minus 6 divide to 1. And in the third fraction, y minus 3 divides out y minus 6 divides out. We are left with 9 y minus 6 minus 4 y minus 3 equals 18. Step number 4, I want to solve and simplify. Multiply the 9 into the brackets, the negative 4 into the brackets. We get 9y minus 54 minus 4y plus 12 equals 18. Combine our like terms. 9y minus 4y is 5y. Negative 54 plus 12 is negative 42 equals to 18. We don't have a y squared term here, so we just want to move our constants to one side and our variables to one side. So add 42, add 42. 5y equals 60. Divide by 5. Y equals 12. Step 5. We want to verify. 12 is not one of our NPVs, so that's fine. We want to sub 12 into our original equation and make sure the left side is equal to the right side. 9 over 12 minus 3 minus 4 over 12 minus 6 equals 18 over 12 squared minus 9 times 12 plus 18. Nine over 12 minus 3 is 9, so 9 over 9 is 1, minus 4 over 12 minus 6 is 6. 4 over 6 reduces to 2 over 3 equals, I'm going to calculate the right-hand side, 18 divided by, bracket the denominator, 12 squared minus 9 times 12 plus 18, close the bracket, enter, math, enter, enter. We get 1/3, and 1 whole take away 2/3 would leave us with 1/3 equals to 1/3. So y equals 12 is our solution. (3x over x plus 2 minus 5 over x minus 3 equals negative 25 over x squared minus x minus 6. Step 1, let's factor. We can factor the third denominator. 3x over x plus 2 minus 5 over x minus 3 equals negative 25 over x squared minus x minus 6. Two numbers that multiply to negative 6 add to negative 1. X minus 3, x plus 2. Step 2, our NPVs. Factors in our denominators are x minus 3 and x plus 2. When are those equal to 0? When x equals 3 and when x equals negative 2. Those are our NPVs. Step 3, lowest common denominator is x minus 3, x plus 2. Multiply that to each of our fractions. We get 3x times x minus 3 times x plus 2 over x plus 2 minus 5 x minus 3 x plus 2 over x minus 3 minus equals negative 25 x minus 3 x plus 2 over x minus 3 x plus 2. In the first fraction, we can divide out x plus 2, x plus 2. Second fraction, divide x minus 3, x minus 3. Third fraction, x minus 3, x minus 3, and x plus 2, x plus 2. We then have 3x times x minus 3 minus 5 times x plus 2 equals negative 25. Step 4, solve and simplify. 3x multiplied into our brackets gives us 3x squared minus 9x. Minus 5 multiplied into our brackets gives us negative 5x minus 10, and then equals to negative 25. I have an x squared term that I'm not going to be able to get rid of, so I want to move everything to one side and then factor or quadratic formula. I'm going to add 25 to both sides. I get 3x squared minus 9x minus 5x is minus 14x, and then adding 25 to negative 10 is plus 15, is equal to 0. I now need to solve that trinomial. 3x squared minus 14x plus 15. There's no common factor, 3, 14, and 15. So this is a complex trinomial, which means we have to multiply 3 times 15, which is 45. We want two numbers that multiply to 45 and add to negative 14. Those would be negative 5 and negative 9 multiply to positive 45. Negative 5 and negative 9 add to negative 14. It's a complex trinomial, so we need to use the box method from here. Top left, 3x squared. Bottom right, 15. Negative 5x and negative 9x in the other two, in any order. First row, 3x squared and negative 5x. It's going to be a positive x. Second row, negative 9x and 15. It's going to be a negative 3 because the first term is a negative. First column, 3x squared and negative 9x. Common factor is 3x. And the second column, negative 5x and 15. It's going to be negative 5 because the first term in the column is a negative. That means our trinomial factors to 3x minus 5 times x minus 3 equals to 0. Let's solve that. When is 3x minus 5 equal to 0? When 3x equals 5. So when x equals 5 over 3. And when is x minus 3 equal to 0? When x equals 3. Step 5 is to verify. Checking our solutions with our NPVs, we actually see that one of our NPVs is 3, and x equals to 3 was one of the possible solutions. So we would say, no, this is not a solution. It's an extraneous root because it does not work in the original equation. And then x equals to 5 over 3, we need to check by plugging in. We have 3 times 5 over 3 over 5 over 3 plus 2 minus 5 over 3 minus 3 equals negative 25 over 5 over 3 squared minus 5 over 3 minus 6. I'm going to plug this into my calculator. Left side, 3 times 5 divided by 3 divided by brackets for the denominator, 5 over 3 plus 2, close the brackets, and then minus the next fraction, 5 divided by, brackets for the denominator, 5 over 3 minus 3. Close the bracket, enter, math, enter, enter, gives me 225 over 44. Let's check if the right side is equal to that. Negative 25 divided by, brackets for the denominator, brackets for the 5 over 3, close bracket, then squared, minus 5 over 3 minus 6, close bracket on the denominator, enter, math, enter, enter, 225 over 44. Left side equals to right side. Therefore, our solution x equals to 5 over 3 is a solution to the equation. (3x minus 2 over x squared minus 4 equals 4 over x minus 2. Step 1, factor. 3x minus 2 over x squared minus 4 is a difference of squares. Factors to x plus 2, x minus 2 equals 4 over x minus 2. Step 2, our NPVs. We have x plus 2, x minus 2 in our denominator. When is that equal to 0? When x equals negative 2 and when x equals 2. Step 3, our lowest common denominator is x plus 2, x minus 2. Multiply that to each of our fractions. 3x minus 2 times x plus 2, x minus 2 over x plus 2, x minus 2 equals 4 times x plus 2, x minus 2 over x minus 2. In the first fraction, x plus 2 divides with x plus 2 and x minus 2 divides with x minus 2. In the second fraction, x minus 2 and x minus 2 divide. We're left with 3x minus 2 equals 4x plus 2. Step 4, let's solve and simplify. 3x minus 2 equals 4 multiplied into our brackets, 4x plus 8. This is a linear, so we want to move x's to one side, not x's to the other. I'm going to subtract 3x and subtract 8. I then get negative 10 equals 4x minus 3x is x. So x is equal to negative 10. Step 5, I want to verify. Negative 10 is not one of our NPVs. Let's plug negative 10 into the original equation and make sure that the left side equals the right side. Three times negative 10 minus 2 over negative 10 squared minus 4 equals 4 over negative 10 minus 2. That's negative 30 minus 2 over negative 10 squared is 100 minus 4 equals 4 over negative 12. Negative 30 minus 2 is negative 32. 100 take away 4 is 96. And 4 over negative 12 is negative 1 over 3. 32 times 3 is 96, so this is negative 1 over 3 equals negative 1 over 3. We've verified that our solution is x equals negative 10. Onto some word problems. I personally think these are the most challenging type of word problems in the course, but they all kind of follow a similar process. So if you can remember the generalizations, that might help. Two types of problems we have. The first one is work type problems. Work problems typically have to do with different people or things working together and alone at different rates. The easiest way to work these problems is to remember that the ratio of time together over time alone for person A or item A plus time together over time alone for person or object B equals to 1, or whatever part of the job is done. So if half the job is completed, it would equal to 1/2. Example, Ever takes 4 hours to paint a room. It takes Taves 3 hours to paint the same area. How long will the paint job take if they paint a similar sized room together? We're trying to find the time that it takes for them to paint this room together. That's what we're going to let our variable equal. Let x equal time it takes together. Our rational equation would then be the time together, which is x, over the time alone. So for Evra, takes her 4 hours, plus the time together, which is our x, over the time alone for Taves, which is 3 hours, equals to 1, because we are asking how long it takes for them to complete the job. Completing the job would be 100% or 1. Now we can solve like normal. We don't need to factor anything. Our NPVs, we don't have any variables on the bottom, so our NPVs are none. Our lowest common denominator, 4 and 3. What's the lowest common multiple of 4 and 3? It's 12, which is 4 times 3. We're going to multiply the lowest common denominator to each of our fractions. We get x times 4 times 3 over 4 plus x times 4 times 3 over 3 equals 1 times 4 times 3. We can divide out the 4's in the first fraction, divide out the 3's in the second fraction. We're left with 3x plus 4x equals 1 times 4 times 3 is 12. Combine our x's, 7x equals 12. Divide by 7, x equals 12 over 7. We want our answer in time, so 12 over 7 is not a very good time. 12 divided by 7 is 1.71, so x equals 1.7142 ... hours. If we want this in hours and minutes, we can take this portion. Remember, it wouldn't be 1 hour and 71 minutes because hours are not out of 100 minutes. So we take the decimal portion and multiply it by 60 minutes because there's 60 minutes per hour. If we take our answer and subtract 1, we're left with just the decimal. If we times that by 60, we get 42.85. So x equals 1 hour and 43 minutes if we round to the nearest minute. Then we can write a statement. Since this is a word problem, it will take them 1 hour and 43 minutes to paint the room together. The next type of problem is a distance equals speed times time problem. Competing in an endurance race, Shannon cycled for 120 kilometers and then swam for 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. If her average swimming speed is X kilometers per hour, find her average cycling speed. So we have two different activities. We have cycling and swimming. It tells us her average swimming speed is X. So speed, swimming, that's X. It also tells us that she cycled for 120 kilometers. So the distance for cycling is 120 and swam for 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed. Her average swimming speed is X. So her average cycling speed was 8x. Shannon took 9 hours to complete the race. So that means the total time equals 9 hours. We don't have any information about the time, but we know that speed times time equals distance. And we have the speed and the distance for both of our activities with variables. So we can write something to represent the time for each. If we have speed times time equals distance, but we want to write time, we would divide both sides by s to get time equals distance divided by speed. In our case, for cycling, time would equal the distance, which is 120, divided by the speed, which is 8x. And for swimming, the distance was 12 divided by the speed, which is x. Once our table is filled in, we can write an equation. We should always have some other piece of information that doesn't fit in our table, which for us was the total time equals 9 hours. We have expressions to represent the time for each activity, so we can write the equation 120 over 8x, which is the time spent cycling, plus 12 over x, which is the time spent swimming, is equal to 9 hours, the total time it took her to complete the race. And then we can solve. There's no factoring to be done here. Our NPVs, x cannot equal to 0, which it wouldn't anyways because she can't swim at 0 kilometers per hour and go 12 kilometers. Doesn't make sense. Multiply, or lowest common denominator would be 8x. We want to multiply our equation by 8x. We get 120 times 8x over 8x plus 12 times 8x over x equals 9 times 8x. In the first fraction, 8x divides with 8x. In the second fraction, x divides with x. We're left with 120 plus 12 times 8 is 96. 9 times 8 is 72x. 120 plus 96, 216 equals 72x. Divide 216 by 72, we get 3. So if x equals 3, that is our swimming speed. The question is asking us to find her average cycling speed. So we've got the swimming speed. Now we want to find the cycling speed, which we know is 8x. 8 times 3, which is 24 kilometers per hour. Last example. A train has a scheduled run of 160 kilometers between two cities in Saskatchewan. If the average speed is decreased by 16 kilometers per hour, the run will take 0.5 hours longer. What is the average speed of the train? We have two scenarios. We have the train going slower on the trip, and we have the train going faster on the trip. It's telling us that the train is going slower or faster for the entire distance, which is 160 kilometers, and it would be the same for both. Let's let x be the faster speed of the train. So faster speed is x. Then the slower speed, it says if the average speed is decreased by 16 kilometers per hour, so x minus 16. Then we need to determine our time, just like we did on the last question. We have speed times time equals distance. If we want to know time, we divide by s. We get time equals distance over speed. So time at the slower speed would be 160 divided by bracket x minus 16. And time at the faster speed would be 160 over x. There's one piece of information in our question that doesn't fit into our table. The run will take 0.5 hours longer at the slower speed. That doesn't go in our table, so that's the part we're going to use to write our equation. We have the slower time equals the faster time plus half an hour. The slower time is 160 over x minus 16, which is equal to the faster time, which is 160 over x plus half an hour. There's our equation. Now we can solve it like we normally do, starting with what are our NPVs? We have x minus 16, so x equals to 16 would be an NPV, and we have x on the bottom, so x equals to 0 would be our NPVs. We want to multiply the lowest common denominator to the entire equation. What is the lowest common denominator? Each of our denominators is different, x minus 16, x and 2. They're not multiples of each other, so the lowest common denominator would be the product of all of those denominators, x minus 16 times x times 2. Multiply that to each of our fractions, 160 times x minus 16 times x times 2 over x minus 16 equals 160 times x minus 16 times x times 2 over x plus 1 times x minus 16 times x times 2 over 2. In the first fraction, we can divide out x minus 16, we can divide out x from the second fraction, and we can divide out 2 from the third fraction. We're left with 160 times 2 is 320 times x is 320x equals, again we have 160 times 2, so 320 times x minus 16 plus x minus 16 times x. Let's simplify. 320x equals 320 times x and then times negative 16. (320 times negative 16 gives us negative 5,120. And then we want to multiply the x into this set of brackets plus x squared minus 16x. Let's subtract 320x from both sides. This is 0 and this is 0. So we have 0 equals, let's write it in standard form, x squared minus 16x minus 5120. I'm not going to try to factor this, so let's use the quadratic formula. Our a value would equal 1, b equals negative 16, and c is negative 5,120. Quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac, all divided by 2a. Let's sub in our information. X equals negative, bracket negative 16, plus minus the square root of bracket negative 16 close bracket squared minus 4 times a, which is 1, times c, which is negative 5,120 close bracket. All of that divided by 2a, which is 2 times 1. Let's calculate what's under the root sign. Bracket negative 16 close bracket squared minus 4 times 1 times negative 5,120 gives us 20,736. We get x equals negative 16 is just 16 plus minus square root of 20,736 divided by 2. Let's calculate each situation, the plus and the minus. Starting with the plus, I want brackets around my numerator. Bracket 16 plus the square root of 20,736. Then I want to close the bracket. I'm going to move over so I'm outside my square root, then close the bracket, then divide by 2, and we get 80. And then if we go back up and alter that equation to have 16 minus, we get negative 64. Okay, what does this represent? X, we saw up here, we defined x as the faster speed of the train. So x is a speed, which means it can't be negative, so it can't be this one. That means this is the faster speed of the train is 80 kilometers per hour. Then the slower speed is 80 minus 16, because it was x minus 16, which equals 64 kilometers per hour. And let's remind ourselves what the question's actually asking us. It says, what is the average speed of the train? The average speed would be if we take the two speeds and divide them by 2, because there are two different speeds. So if we take average would be our faster speed, 80 kilometers per hour, plus our slower speed, 64 kilometers per hour. Add those together and divide by 2. We get 144 divided by 2, which is 72 kilometers per hour for the average speed. That brings us to the end of Chapter 6, Lesson 4.